guys, so today we're going to continue talking about the graphs of sinusoidal functions. We talked about two of the transformations, which was stretch and compress, both vertically and horizontally. Today we're going to talk about shifting left and right, up and down. So since we already know our transformations, this shouldn't be too difficult. It is just the drawing the curve that gets a little bit tricky. So as a reminder, there's our sine and cosine functions, just parent function whenever there is no transformations on them. For sine, the critical points you want to think of is it starts at the midline, it goes up to a max, goes back to the midline, goes down to a min, and then back to the midline. So when we are drawing sine functions, you're going to want to think about those 5 critical points. For cosine, it starts at a maximum, goes down to the middle, then down to a minimum, back up to the midline, and then back up to the max. So while both graphs will make that same wave, they'll look the same, you have to think of the critical points differently. Okay, so when we look at these functions, we're going to look at them in this order. A and D both do vertical transformations. So A and D are going to affect your y-axis. So what we learned on Friday is that A will always be the amplitude. That's going to be how tall the waves are. So right here, that's A. Or you could go down to minimum, that's also A. Either way, just the distance from max to midline is A. D is what's going to shift up and down. So we didn't talk about this on Friday, but it's very easy to understand. If you have minus D at the end of your function, you're going to move D units down. And then if you have plus D, you're going to move up. The way we do that is by moving our midline. So for our parent functions here, midline is always right here on top of the x-axis. But when you have a vertical shift, that line is always going to be at y equals d. So whatever number you have at the end. Same thing for cosine. That horizontal line is always going to be at y equals d. Okay, the other two transformations are B and C. Those two transformations control horizontal. So the period is how long it takes for the function to complete one complete cycle. For sine, you want to look at it like this. It kind of looks like a snake. So period is that long. So for the parent function, it's automatically 2 pi. And as well for the cosine, it's also automatically going to be 2 pi. But if they give you a value for B, that'll change. It might either stretch your wave out or it might squish your wave in. So the way you'll find period is by dividing by B. The thing we haven't talked about is when there's a C value here, when they're subtracting something on the inside of parentheses. So it works just the same as it did before. That controls shifting left and right, but it is opposite of what you would think. So if it's minus, you're going to move to the right. If it's plus, you are going to move to the left. The way we see that on our graph here is, see my little cycle that I highlighted on both of them? For both, I started at the y-axis. I started at x equals 0. That's actually going to be your phase shift. That's going to be how you move left and right. So for parent functions, it starts at 0. But for every other function, it's always going to be at x equals C. X equals C. So that's going to make it a little bit trickier when you're trying to calculate period, but we'll do examples. Okay, so those are all our transformations. Now let's practice actually graphing these. So first one we have is f of x equals 3/2 sine x plus 3. So in my little examples up here, I was using theta as my input. Here they're using x as their input. It works exactly the same way. So let's go in order. Amplitude is always my a value, and a is 3/2. So that part was easy. Amplitude is 3/2. Okay, then period is always 2 pi divided by b. B is always in front of theta or in front of x. There's nothing there, so technically that b is a 1. 2 pi divided by 1 is still 2 pi. Okay, phase shift. Phase shift is C. Has to be in parentheses. There's no parentheses here, so that means that our phase shift is 0. It is not moving left or right. And then vertical shift, plus 3 at the end. So that means that it is going up. That also means that our midline is going to be at y equals 3. Now let's get all of this information and put it onto our graph. So I'm going to do what I did on Friday, where I'm going to try to use a light color as my guidelines, and then we'll draw on top of that. So I actually start with my midline. Midline is going to be at y equals 3. So that's going to be up here. That's our midline. Okay, then I go up to amplitude. So I'm doing my vertical transformations. Amplitude is 3/2. So if this is the middle, I'm only allowed to go 3/2 up and 3/2 down. So I know that 3/2 is 1.5. So I'm going to count 1.5 up. And that's going to be our maximum. And then I'm going to count 1.5 down. And that'll be our minimum. So our wave has to stay in between those dotted lines. Okay, and then for now, phase shift is 0. It's not moving left or right. So I'm still going to draw this. I'm going to start at the y-axis at x equals 0. So that's my phase shift. And then period is 2 pi. Since we're starting at 0, it's easy to count. 2 pi is going to end where it says 2 pi. And then that is the period. So after doing all these guidelines, you should end up with a kind of rectangle shape right here. We want to do one complete cycle of sine in that rectangle. So remember those critical points of sine. Sine starts at the mid, goes up to a max. Okay, so we need to start at the mid. Oh, let me change color here. Start at the mid, end at the mid, and then right in the middle also hits the midline. Then between these first two, it needs to hit a max. I'm counting 4 squares, so in the middle is going to be 2 squares. And then between the second two is a min. And then just connect these points using curves. You don't want it to look pointy. You want it to be round. Okay, so that's one complete cycle, but you have to continue the pattern. You can't just draw one cycle. You have to keep going until you run out of space. So it looks like every 2 squares is where it changes. So if I were to go 2 squares backwards, I need to hit that minimum. And then 2 squares backwards from that is back to the midline. 2 squares is a max. And then 2 squares is back to the midline. Okay, so another cycle of sine. And then the rest, since we only have 1 square, I know it's going to go up. Let's put an arrow down, arrow, because it continues forever. Okay, so this one should hopefully felt straightforward because there was no horizontal transformations. It was only vertical. Okay, let's try the next one. So this time I have cosine of 2, parentheses x minus 3 pi over 4 minus 4. So amplitude is always going to be the number in the front. There is no number in front, so we know that means invisible 1. Okay, period is 2 pi divided by b. On this one, I do have b. b is in front of the parentheses, so b is 2. 2 pi divided by 2 is just pi. So this is actually getting horizontally compressed. It's getting kind of squished in. Our phase shift, we have 3 pi over 4 inside the parentheses. But it's minus, so that means that we're going to move to the right. Vertical shift, We're going to move 4 down because that's a minus. So our midline is going to be at y equals -4. Up here for phase shift, I'm just thinking about it now. We should probably write where it's going to start. So instead of starting at x equals 0, we're going to start at x equals 3 pi over 4. So I know that this is a minus, but we're starting at positive because we're moving to the right. Okay, let's get all this information onto our graph. Okay, so midline is at -4. So I'm going to do my dotted line all the way down at -4. That's midline. Since it has an amplitude of 1, its minimum can only go 1 below that, and its maximum can only go 1 above that. Okay, so here's the part that gets a little tricky. So phase shift, we're going to start at 3 pi over 4, but we're going to the right. If this is pi, this is 2 pi. It looks like it takes 4 squares to get to pi. I want 3 pi over 4, so I want 3/4 of pi. So lucky for us, if it's 4 squares and we want 3 of them, we're going to stop right there. Or start, I mean. So that's our phase shift. That's where we're going to start our cycle. I'm going to write this sideways. Phase shift. Okay, and then from there, we need to have a period of pi. So it's not as easy as just drawing a line where pi is. I need to be pi away from my phase shift. So again, 1, 2, 3, 4. It takes 4 squares to equal pi. So starting from my phase shift, 1, 2, 3, 4. I would need to end here. Another way to do this is to actually do the math. So I'm going to do that here on the side. So phase shift plus period. Okay, so our phase shift was 3 pi over 2. Or sorry, 3 pi over 4. And our period is pi. The thing about adding fractions is it needs to have the same denominator. So instead of just pi, I'm going to call that 4 pi over 4. And then I could just add across. 3 plus 4 is 7 pi over 4. Okay, so when you go and you count, 1, 2, 3, 4, 5, 6, 7. See how it's landing there? Okay, so now you have a little rectangle here at the bottom. We need to fit an entire cycle of cosine into that rectangle. So cosine has different critical points than sine does. So for cosine, you need to start at a max and end at a max. Okay, so let's do that here. Start at a max, end at a max. Right in the middle, you have a min. And in between those extrema, you hit the midline. So this looks like this so far. But like we did before, we're going to continue that pattern over and over until we run out of space. So it seems like every 1 square, it hits another critical point. So I'm just continuing my pattern. And it should look something like that. Okay, on the back, we have 2 more examples. Again, it's going to be one of them is sine and one of them is cosine. Okay, so this one here, f of x equals 3 cosine x plus pi over 2 minus 2. Amplitude is 3, because that's the number in the front. Period is always 2 pi divided by b. Since there is no b, it's an invisible 1 right there, so it's still going to be 2 pi. Our phase shift, this number here, pi over 2. But because it's a plus sign, you're going to move to the left. That means that our starting point, so I'm going to do this here, is that x equals negative pi over 2. It's always opposite of what you see. Okay, then vertical shift, we have a minus 2, so that means it's going to move 2 down. Our midline is at y equals negative 2. Okay, so I'm going to start with our midline. Okay, it has an amplitude of 3, so that means our maximum would be 3 squares up. And our min would be 3 squares down. It has a phase shift of pi over 2 to the left. So that's 2 squares, because remember each square counts as pi over 4. 2/4 would equal 1/2. So phase shift. Okay, then it needs to have a period of 2 pi. So 2 pi is right here. That doesn't mean it's going to end there because we didn't start at 0. We're starting 2 squares before 0. So you could just do the shortcut and do 2 squares before the 2 pi. So period equals 2 pi. Or you could do the math like we did before. Negative pi over 2 plus 2 pi, but I'm going to go ahead and put it into common denominator. So that would be, 4 pi over 2. And when you add that, is 3 pi over 2. So notice how it's right in between the pi and 2 pi, so that we did it correct. Okay, now all that's left is to put the cosine cycle into this rectangle space here. Starts at a maximum, ends at a maximum. Has a minimum right in the middle. And then in between those extrema, it hits the midline. So I'm just counting the squares. It looks like every 2 squares is where it has a critical point. And then you connect using curves. And then we just continue this until we can't anymore. So every 2 squares to another critical point. Okay, and then one last one for us. We have 4 sine 2/3 of x plus pi and then plus 1. Amplitude is 4. It starts with a 4. Period is 2 pi divided by b. b is 2/3. So hopefully y'all remember how I showed y'all when you're dividing by a fraction, you can multiply by its reciprocal. So this turns into 3 pi. Phase shift is it's going to go pi to the left. It has a plus sign, so that's left. So we're going to start at negative pi. Vertical shift is 1 up. So our midline is going to be at y equals 1. Okay, now let's put all of that onto here. Y equals 1, that's our middle. Amplitude is 4, so I would go 4 up, and that's our maximum. 4 down, and that's our minimum. Phase shift is it's going to go pi to the left, so I can start at negative pi. Then it's going to take 3 pi, but that's basically negative 1 plus 3 is going to stop at 2 pi. So our entire sine cycle needs to fit in here. So critical points of sine. It starts, it ends, and then right in the middle it hits the midline. So I'm going to count. It's 12 squares. So if I want in the middle, I'm going to have to do 6 squares. So that's right here. And then between those middle points, between the first 2, it hits a maximum. So that'll be after 3 squares. And between the second 2, it hits a minimum. and then continue that until you run out of space. On the right side, I know we're not going to have much, so I'm just going to extend it. On the left, every 3 squares, we almost had enough for another bump. So there are our sine and cosine transformations using all 4 transformations: vertical and horizontal dilations and vertical and horizontal translations. Right, let me know if you have any questions on this, and we'll continue this tomorrow. All right, bye guys.